So let's talk about, now that we understand what an atom looks like, let's talk about the numbers that are on that periodic table. Okay. If you look on the periodic table, and let's say that you were to look at the very first element in the top left-hand corner, that would be hydrogen. And you'll notice that there are two numbers. And it's not just on hydrogen, but all the elements have two numbers. And both those numbers actually mean something in terms of the protons, neutrons, and electrons. So we'll start with the whole number. Every single element has a whole number associated with it. Hydrogen is number 1. That is called the atomic number, right? And the atomic number is the number of protons in the nucleus of an atom of that element. So all hydrogen atoms have 1 proton. Okay. In fact, that's their defining characteristic. It doesn't matter how many neutrons they have. It doesn't matter how many electrons they have. If they have 1 proton, they are known as a hydrogen atom. So the other number that you have here, which usually includes some kind of decimal with it, is an atomic mass. And it turns out that it's an average atomic mass, and we're going to talk about why specifically in a little bit. But those two numbers are going to become really important. They are not numbers you need to memorize, because you will be able to have a periodic table out in front of you or on a separate tab anytime we take a test or a quiz in here. Okay, so you don't have to memorize those numbers, but you do need to know what those numbers mean. So we just said that hydrogens always have 1 proton, right? And again, it doesn't matter how many neutrons. They could have no neutrons. But as long as they have 1 proton, they would be hydrogen. And if you look on the periodic table, you'll notice that uranium, which is way down at the bottom there, uranium has 92 protons because its atomic number is 92. And so all atoms that have 92 protons, again, no matter how many neutrons they have, no matter how many electrons they have, if they have 92 protons, they're uranium atoms. So here's what we've learned so far. The atomic number is the number of protons, right? But we also know that protons are positively charged and atoms are neutral. That means that if they have positives, they must also have negatives that cancels out the positives. So it turns out that if you know the atomic number, which is the number of protons, you also know the number of electrons in the atom, because the electrons, which are negative, must equal the protons, which are positive, right? Because they cancel each other out, and that's why the entire atom ends up as a whole neutral. Now, we know how to find protons. We now know how to find electrons. How do we find neutrons? Well, that is not on the periodic table. You need a separate number to help you with the neutrons, and that number is called the mass number. So the mass number is the number of protons plus the number of neutrons. This is not the exact same number that you see with the decimal. That's not the average atomic mass. That's a slightly different number. The mass number is the number of protons and neutrons in the nucleus of the atom. So the atomic number, that's on the periodic table. That's that whole number. But the mass number, as I just said, that's not the same as the average atomic mass. The mass number is not on the periodic table. It would have to be given to you. Now, how do you know when you're being given a mass number? They don't just come out and say, here's the mass number. So how do you know when you're looking at it? Well, you're going to see two different formats. One is called the nuclear symbol. Okay? So this is what we call the nuclear symbol, and it's that because we have the symbol of the element. So in this case, we're talking about carbon, right? And then we have 2 numbers next to it. In the top left-hand corner is the mass number. The bottom left-hand corner would be the atomic number. However, they don't have to give you that, because remember, you can always look that number up on the periodic table. We could look up carbon and find out that it's number 6 on the periodic table. But we wouldn't necessarily know what the mass number is, and that's why that would have to be given to us. Now, it wouldn't have to be in this form. They could also write out the name carbon and then put a dash and put a number after that. That number is the mass number. All right? So when you are given an element, if neutrons are important for you to know, then they would have to give you the mass number along with it. All right? So let's do a little bit of practice here. If you're given a nuclear symbol, can't you figure out how many protons, how many neutrons, how many electrons there are? So let's do this first one. So first off, you should be looking at the periodic table. Okay, so again, if you don't have one available, then pause and go pull a periodic table up from a website or from Google Classroom or from some place so that you can be looking at it while we do this, because it's important that you have that. So the first thing you should be able to do is tell me what element this is. So we know, since this is capital H stands for hydrogen, right? That's that element way up in the top left-hand corner of the periodic table. All right, now they've given us 2 numbers. Remember, the number in the top left-hand corner is the mass number, and the bottom left-hand corner is the atomic number. So if I asked you how many protons there are, remember, protons is equal to the atomic number. So how many protons? There must be 1. How many neutrons there are? Well, neither one of these numbers, neither the atomic number nor the mass number, actually stands just for neutrons on its own. Remember, atomic number has nothing to do with neutrons, and the mass number is protons plus neutrons. So if I want the neutrons by themselves, and I don't want to know anything about the protons, I'm going to have to subtract the protons out of this number. So in other words, if you take mass number minus atomic number, that should give you just neutrons. So mass number, which is 1, minus atomic number, which is 1. Well, what's 1 minus 1? 0. So this particular atom happens to have 0 neutrons. And yes, that's fine. You don't have to be an atom and have a neutron. You do have to have at least a proton, but you don't have to have a neutron. It's not some kind of law that says neutrons have to be there. All right, and then finally, let's end with the electrons. How do we find the number of electrons? Well, we said before, electrons equal protons when we're talking about atoms. So if this has 1 proton, guess what? It has 1 electron. Okay, let's try another one. Again, you've got a piece of paper out, you're taking notes, so that means you can try this out without having me say the answer for you. So if you think you're ready, if you want to try this one out, and I think you should try to do it, I want you to pause here, and I want you to try to figure out for this element here, how many protons, how many neutrons, how many electrons does it have? Okay, so hopefully you've tried that out on your own. Let's go through the answer. First of all, what element is this? Ne. If you didn't know, you'd look up on the periodic table, you find that Ne stands for neon, right? So this is the element neon. We know that the mass number is 22. We know that the atomic number is 10. So how many protons? Well, the atomic number always equals the protons, so there's 10 protons. How do you do neutrons again? Remember, neutrons is always mass number minus atomic number. So 22 minus 10 says there's 12 neutrons. And then how many electrons? Well, the electrons have to equal the protons. So if there's 10 protons, there's 10 electrons. Right? Okay, let's try one more. Ooh, some big numbers. That's all right, though. You can do this. You can even use a calculator, by the way. Okay, if you're like, well, that's That's a lot of subtracting to do in my head. Well, you don't have to do it in your head. If you want to use a calculator, go ahead. All right, this is not math class. I don't need you to sit there and try to figure it out in your head. But do try to do this one on your own. Go ahead and pause and try this on your own. Okay. So, here we go. So I know that this is uranium, first of all, right? Because it's U. U stands for uranium. This is uranium-238, because that's the mass number. And uranium always has an atomic number of 92. So how many protons? Must be 92. How many neutrons? Well, we would have to take 238 minus 92, and that would be 146. And how many electrons would there be? Well, that should be the same as the protons, right? 92. So at this point, you should be getting pretty familiar with what to do with these numbers. You should be able to take any element on the entire periodic table and tell me how many protons, neutrons, electrons it has, as long as you were given the mass number, right? Now, protons are the defining characteristic for an element, right? Like we said before, hydrogen always has one proton. How many neutrons it has and how many electrons it has actually doesn't matter. It only has to have one proton to be called hydrogen. If it has 92 protons, it's uranium every time. Neutrons and electrons can change, however. They don't always have to be the same. We just said that uranium had 146 neutrons. Do all uraniums have 146 neutrons? Nope. So, if the number of neutrons changes, then you have something called an isotope. So an isotope is an atom that has the same number of protons, but different numbers of neutrons. So in other words, it has the same atomic number, it's the same element, but it has a different mass number because it has a different number of neutrons in it. Let me give you a good example of this. Okay. Magnesium, one of the elements on the periodic table, right? Magnesium has 3 isotopes. There's magnesium-24, there's magnesium-25, there's magnesium-26. Now remember, those numbers are the mass numbers. So this is magnesium with 24 protons and neutrons. This is magnesium with 25 protons and neutrons. And this is magnesium with 26 protons and neutrons. So how do you know how many protons are in these? Well, that's always the atomic number. Remember, that can't change. If you look up magnesium on your periodic table right now, I'll give you a moment to do that. You looked up magnesium, right? Magnesium is number 12. So that's atomic number of 12. So how many protons does magnesium have? Well, it has 12 every time. So that doesn't change. But how many neutrons does it have? Well, if this is the mass number and this is the atomic number, mass number minus atomic number tells you neutrons. So how many neutrons does magnesium-24 have? Well, what's 24 minus 12? It's 12. So that means that this magnesium-24 has 12 neutrons. So how many neutrons does magnesium-25 have? Well, what's 25 minus 12? That's 13. So this magnesium isotope has 13 neutrons. And of course, then this magnesium isotope, 26 minus 12 is 14. So it has 14 neutrons. So again, these are isotopes. I always think of isotopes like they're like brothers and sisters. They're like your siblings, right? You're really similar to each other. You come from the same family, right? You have very similar DNA, but you're not exactly the same. Okay. So magnesium-24, magnesium-25, magnesium-26, they're all isotopes of each other. They're all a magnesium, but they're not exactly the same as each other, right? And then let's do electrons just to finish this off. How many electrons would they all have? Well, if they have 12 protons, I gotta have 12 electrons, right? That's what being an atom means. You have protons and electrons would be the same in an atom. But what if the electrons weren't the same as the protons? What would you call that? You call that an ion. So an ion is an atom that actually has more or less electrons than the protons. So in other words, the electrons and protons are not equal. And if that's the case, that means your negatives and your positives aren't completely canceling each other out. And so an ion always has a leftover charge. It either has leftover positive charge or leftover negative charge to it. So how do you figure out the number of electrons in an ion? Well, you take the atomic number again, but this time you have to subtract what the charge is. So here's how that looks. So this is the element barium, right? Ba is for barium. You can look that up on the periodic table. This happens to be the isotope barium-137, right? That's why we have the mass number of 137. Now, what's the atomic number of barium? Well, you'd have to look that one up. That does not have to be given to you. You can always look up atomic numbers on your own on the periodic table. So barium's atomic number, we know, is 56. So it has 56 protons. Now, how do you do neutrons? Once again, you take mass number minus atomic number. So 137 minus 56. So what's that going to be? 81. Now, let's cover electrons. Since there is a charge of +2 on this, we take the atomic number minus the charge. So the atomic number was 56. 56 minus +2. So 56 minus 2 is 54. So we only have 54 electrons in this case. And this is why we have a +2 charge, because we have 2 positives more than we do negatives. Okay? All right, let's try one more. Again, this time you try it. See if you can get the right numbers. Truly pause this. Don't just wait for me to say the answers. That doesn't help you at all, right? You need to try it on your own. So pause this for real. Try to do it. Even if you're wrong, you'll still learn. That's good. Okay. You really did pause, right? Okay, good. So, first of all, what element is this? P stands for phosphorus, right? So this is phosphorus. This is phosphorus 31. And it has a -3 charge. So all things that are going to be important. So let's start with the atomic number for phosphorus, the number of protons. So you've looked up phosphorus already, right? Phosphorus is 15 in the periodic table. So it has 15 protons. How many neutrons? Well, 31 minus 15 gives you 16. So it has 16 neutrons. How many electrons? So remember how we do electrons again? Atomic number minus charge. So the atomic number is 15. The charge is -3. So 15 minus -3. If you minus a negative, what are you really doing? Aren't you really just adding, right? Minus a negative is add. So this is really saying 15 plus 3. So that's 18 electrons. By the way, you'll know that you're doing it right when you look at the charges. We have 18 negatives, but we only have 15 positives. So that means that we have 3 negatives left over. Oh, look, that's what the charge is. Okay? All right. So at this point, you should be able to take a periodic table, and you should be able to take any element on that periodic table and tell me how many protons, how many neutrons, and how many electrons it has, as long as I gave you the mass number and a charge if it has a charge, okay? All right. Now, we've talked a lot about the atomic number. That's the whole number that was on the periodic table. But there was that other number on the periodic table known as the average atomic mass. Now, that's different than the mass number. Remember, a mass number is a specific mass, a specific number of protons plus neutrons that are in each individual isotope. But if you were to ask somebody, what's the atomic mass of an element as a whole, that would be really hard to do, okay? First of all, masses for atoms, we cannot measure in normal units, okay? We cannot measure them in kilograms or grams or even milligrams would be too much, too big, okay? Atoms are way too small for those kind of units. So we've come up with a unit just for atoms, and it's called the atomic mass unit, the AMU. All right, so anytime that we talk about the mass of an atom, we're talking about it in terms of AMUs. And if you want to get a general idea of how big an AMU is about the same size as the mass of one proton or one neutron. So instead of having to think about protons and neutrons in terms of grams or kilograms or something crazy like that, we just think of them in terms of AMUs. So one proton is basically one AMU. One neutron is about one AMU. Okay? It's not exactly one AMU, but it's close enough. Okay. So when we talk about an element has multiple isotopes. If you remember, we were just talking about the isotopes for magnesium, right? Magnesium has magnesium-24, magnesium-25, magnesium-26. And if somebody said, how much does magnesium weigh? And most people would be like, well, which one are you talking about? Are you talking about magnesium-24? Well, it weighs 24. Well, magnesium-25, it weighs 25. Magnesium-26 weighs 26. So which one are you talking about? Well, I just want the average. Okay, well, we can take an average, but it would be a weighted average. It's not going to be just a straight average. You're not going to take 24 plus 25 plus 26 and divide by 3. And the reason you're not doing that is because not all of the isotopes of an element are found equally in nature. In magnesium-24, magnesium-25, magnesium-26, out of those 3, one of them is probably much more common than the other 2. And therefore, you can't just take a straight average like you normally would think. So let's do an example here. All right, boron has 2 naturally occurring isotopes. Okay, so there's boron 10. That means it has its protons and neutrons add up to be 10. And then we have boron 11. So its protons and neutrons add up to be 11. Okay. In fact, we can look on the periodic table at boron, and we know that boron is element number 5. And if it's element number 5, that means that it has 5 protons. So boron 10 must also have 5 neutrons, because 5 plus 5 makes 10. Boron 11 must have 6 neutrons, because 5 plus 6 makes 11. So we know how many protons and neutrons they have. But again, if somebody wanted to know what's the average atomic mass of boron, we can't just take 10 plus 11 and divide by 2. All right, because boron 10, it says here, has an abundance of 19.8%. Now, what does that mean? That means about 20% of the time in nature, you find the isotope boron 10. So boron with 5 neutrons. But boron 11 is found over 80% of the time. So 80% of the time, boron has 6 neutrons instead of 5. And you can see that the exact masses aren't exactly 10 and 11. They're a little bit off of that, but that's all right. We're still going to use those numbers. But we want to calculate the average atomic mass of boron. So again, we're not going to just take 10 plus 11 divided by 2, because we have a lot more 11s in nature than we do 10s. So the way that we're going to do this is we're going to take the mass of each isotope and we're going to multiply by its abundance. So we're going to take the mass of boron 10, which is a little over 10 AMUs, and we're going to multiply by this percentage. And then we're going to do the same thing for boron 11. We're going to take its mass in AMUs, and we're going to multiply by its percentage, and that gives you something called the weight of each isotope. And then we're going to add those weights together, and that will tell you what the weighted average is. So let's go ahead and try it with this example. So boron 10 weighs 10.013 AMUs, according to the problem above. We're going to multiply by a percentage. Remember, when you multiply by a percentage, you have to move the decimal point over 2 times. So when we multiply by 19.8%, we're actually multiplying by the decimal 0.198. And then we're going to do the same thing for boron 11. For boron 11, we have a mass of 11.009 AMUs. And then we're going to multiply by 80.2%, which means we're actually multiplying by the decimal 0.802. So we get the 2 weights of each of these, and we're going to add those 2 weights together. And when we do that, we get 10.81 AMUs. That is the average atomic mass of boron. Now, there's 2 ways that we can make sure that this makes sense and that we know that we're probably correct on this. 1, we know that boron 11 is found much more often in nature than boron 10 is. So if there is going to be an average between the 11s and the 10s in nature, the average should come out closer to 11 because there's more 11s out there, right? And 10.8 is closer to 11 than it is 10, so that makes sense. The other way that we can tell is we could look up boron on the periodic table, and we could tell right away that boron, it says on the periodic table, has an average atomic mass of 10.81. Therefore, we know that we did it right. Okay? So, doing an average atomic mass simply gives you what's the average of all the isotopes for that element. It does not tell you what the mass number of one element is. Okay? All right. And that's it for chapter 4. And then we will move into chapter 25 next. So don't forget that we're moving to chapter 25 and doing both chapters together on the next test.